some of you came up with a different way of doing 3a, one that was different than what I intended, but it's actually easier. So basically, it starts out like this. From the top of the exam or from your notes, you knew that this series is the log of x plus 1, and that was valid for x less than 1, minus 1, and maybe at the endpoints. We're really not sure. The endpoints meaning where x is equal to minus 1, x is equal to 1. So, okay, so that would mean that we can look at the series this way. If I replace whatever I put in here, it's valid as long as u is less than 1 in absolute value, but it may also be valid at u is equal to minus 1 or 1, and you need to test. So I say, okay, therefore the log of 2, x plus 1, that's my u, is going to be equal to this, and u is equal to 2x, so I just get that. That's my formula. And that's going to be where 2x is less than 1, so x has to be less than 1/2 in absolute value. And we'll need to test x equal minus 1/2, x equals 1/2. Okay, so I'm going to split this out a little bit. That's going to be 2 to the x plus 1, x to the k plus 1 over k plus 1. Okay, so now the only thing I don't know about is what happens here, and then I also have to figure out what log 2 is, but if I plug in 1/2, you'll see. Okay, so I'm going to plug in x equals 1/2. If this converges, I'll have the log of 2 times 1/2 plus 1, which is log of 2, and this is going to be equal to this. This series right here, 2k plus 1. I plug in 1/2 k plus 1 over k plus 1. And you see what's going to happen here. I'm going to get a cancellation. So I distribute this exponent. These cancel. And I'm left with summation minus 1 to the k over k plus 1. K is equal to 0. And this converges by the alternating series test. The terms decrease. That's pretty clear if you go ahead and do it. And then this limit minus 1 to the k over k plus 1 is equal to 0. Okay, so this converges, and it converges to log 2. So that's what the log 2 is. We saw that before. So we know that it converges here. Now we still have to test x equals minus 1/2. So again, when x is equal to minus 1/2, I plug that into log 2x plus 1 to the series. And hopefully you'll see what's going to happen. Okay, so I have to plug this into here. Well, you don't really need to plug it in here, but I think something interesting happens, which may help. That's going to be the log of 0. Does not exist. So that means that this probably won't exist, but let's see what happens. We'll go through the problem. I plug in x as minus 1/2. So something a little bit different is going to happen here. I get minus 1 to the k. Here, let me keep that out of the way. 2 to the k plus 1. Here, let's get that like that, in case you want to look at it. Minus 1 to the k plus 1 over 2 to the k plus 1, all over k plus 1. That's going to cancel with that. And notice what I get is this is negative when k is even. This is negative when k is odd. So actually things are always going to be negative, but you'll see that easier if I add the exponents. And that's going to be over k plus 1. Now this is always negative 1. and that's going to be a p-series when p is equal to 1, so it diverges, even if multiplied, diverges to minus infinity, since multiplied by -1, this thing right here. Okay, so that's going to diverge. So the upshot is that log 2x plus 1 is equal to this series. For x less than or equal to 1/2, but strictly greater than -1/2. And what we saw before, that when x is equal to 1/2, I get the log of 2. And that series we saw before was this. Oops. Okay, so that's it. That's just a different way to do the problem.